Hello, welcome to Waterworks Distribution 2 or Advanced Water Distribution. Um, I'm going to be putting together videos for those of you that wish to view these instead of just reviewing the slides. I might give you a little bit more insight into water distribution. But for those of you that just want to skip ahead and review the slides on your own, it's perfectly fine. You don't feel like you need to watch every single one of these videos. All right, with that, let's get started. All right, each class, you should probably have a calculator, some kind of a pencil. That way, you can erase your mistakes when working on your math. The state conversion sheet is always something that you're going to want to have. They have all the formulas that you're going to need for completing any of the math problems that you'll have. It says textbook, however, I provide you with everything that you're going to need. In the past, I did ask that you got the textbook, but um, realize that I was providing everything that you need. So don't feel like there is a textbook that you need. All right. When it comes to your work, I want to see how you are getting to your answers. That way I can assist you in correcting anything that you might have made a mistake on, write legibly so that way I can understand how you are getting from, A to Z. And then showing your units is just as important as showing your work. The units will help you keep track of where you are in the problem and ensure that you are getting the correct answer. And then finally, circling your answer helps me to see what your answer is. In some of these problems, you might have to do several steps and have different numbers written down. So having your answer circled helps me to see what it is you came up with. All right, so here's your conversion sheet. Obviously, it's not real legible here, but I did provide you a PDF version, so please feel free to download, print that out, keep that with you. That way, you're able to solve some of these problems. This sheet was definitely helpful for me when I was going through this program and taking my exams. Being able to become familiar with this is helpful, so that way you're not having to look up and down, left or right, trying to figure out where the formula is when you're taking your exam, because when it comes to it, you get 3 hours. And so not necessarily knowing the formula is important, but knowing where to find the formula could be really helpful to you. It's just a little exam trick or tip, if you will. So what is a distribution system? Well, you can see a water distribution system includes facilities for the purpose of collecting, treating, storing, controlling, and distributing potable water through valves, pumps, pipes, and regulators, etc. That's a definition that you will find in one of the textbooks. But yeah, really, it's everything that is used to deliver water to the end user. Now, whether that end user is a business, a customer, a landscape, it all varies. But essentially, that is what a distribution system is. So, how water works, right? A typical water system is basically how you get water from your sources, whether that be a stream, if it be a lake, groundwater, and moving it through some sort of treatment facility and then out into the distribution system to the end user. The math intent. So during the course of this semester, we will be covering these different math equations with regards to specific gravity production math, stationing, GPD, feed rates, pressure head. We're going to go through all of these different types of math equations to get you prepared for your distribution exams. And for some of you, you may use it in your day-to-day tasks. I know when I was an operator, we used several of these formulas to calculate flows, pressures, and make certain adjustments to our system based on the math that we were creating. Hydraulics, that would be the study of fluids at rest and in motion under pressure. So, how water moves through your distribution system. It is very important to understand how hydraulics work for the proper operation of a distribution system. So, hydraulics is made up of static pressure, dynamic pressure, QAV, friction loss, otherwise known as the Hazen-Williams formula, or some people might be more familiar with what's called the C factor, um, the hydraulic gradient. So, as water moves through the distribution system, um, if you have water at a certain elevation, if there was zero friction loss, if there was a leak, though, as water moved downstream, it would be able to reach that same elevation. However, you have hydraulic gradient, so as water moves away from its source, it's experiencing more friction and less likely, or it's impossible that it would ever reach that elevation ever again. But anyway, a lot more math as we go through this course. You're going to want to understand sources of water, understand, where your water is coming from. It's just as important as some of the math that we're going to be doing, because the source will also dictate the treatment method. It will dictate how much you're likely to have. Um, a lot of times you're going to find that surface water is used to treat large systems, and groundwater is relatively limited in its capacity, just due to recharge rates. You have purchased water. The system that I work for, we purchase all of our water. We do own Lake Henshaw, which is up in the northeast part of San Diego, and that water has to go down to the treatment plant over in Escondido, also known as the Escondido Vista treatment plant, before making its way onto Vista. And then you have rural water systems, which is going to be for any system that is unreachable, or it just it um it just has too long of a run to make before it can actually reach any of the homes. Operation and maintenance would be a lot of what we're going to talk about. Listed below are just some of the topics that we cover throughout the semester. We cover the types of systems. Anyway, these are all the topics that we're going to be covering throughout this semester. So if you're not familiar with some of them, don't worry, we'll get you up to speed. I'm sure some of you have experienced some of this already and might have some base level understanding, which is great. We'll build upon what you already know. All right, you got different classes of public water systems. You are going to want to know what all of these are. You will see these on a test, whether that be a quiz, a midterm, or a final. So please take a few minutes to learn what these are. Wouldn't want you to miss out on these simple questions. Right, you got different types of system layouts. So there's the arterial loop system. In that one, you have large diameter mains, or what we refer to as transmission mains, that are delivering water in various parts of the system. And then the distribution mains are what actually take off from those transmission mains and deliver that water to the end user. Through a arterial loop system, there's not really going to be any sort of dead ends, or it's good for water quality to have that type of a system. Same with the grid system. Grid systems are great because almost no dead ends. The water can come from multiple directions, and that's really good for water quality. Now, tree systems, that's what like a lot of the systems in Vista are. A lot of dead ends, and it's also important to understand this from the Insurance Services Office, or the ISO, because you might not be able to develop areas if you're not able to deliver enough water for firefighting purposes. But there are some systems out there that this is just the most efficient design, and that's why you go with something like that. So here's an example of an arterial loop system. You can see that you have the larger diameters here on the outsides, and it's, you know, delivering the water to the distribution mains that are now set up. Now, in this system, water will flow around in these directions through these arterial mains and to these distribution mains. It's pretty similar. I mean, you will see something similar in a grid pattern, such as this one. You can see you've got, a large transmission main connected to smaller distribution mains. This one's considered a grid system just with how the grid pattern is set up. The city of Escondido is a good example of this. A lot of their system or their city is designed in a grid-like pattern, which is good for water quality. Next, you got the tree system layout. Like I said, lots of dead ends. You got a large transmission main, and distribution mains are connected to that. But then it leads to dead ends. And like I said, that's not good for water quality. Anytime you are designing a system and you have to put in some sort of dead end system, you want to reduce the size of main so that way the end user, let's just say there's a customer right here, you don't want to have an 8-inch main that goes all the way to their house. If you could reduce that to like a 4-inch main, then the water quality might be a little bit better for them. SCADA systems. We'll be talking briefly about SCADA systems. You should have had some experience with this in the Distribution 1 class, but you should know that what it stands for. It's supervisory control and data acquisition. You will see a question like this somewhere along the line this semester. So a true SCADA system is one that gives you the ability to not only monitor but control uh, items such as pumps, regulators, etc., via a remote location. And that is really what differentiates the SCADA system from a monitoring system. All right, so this image that you see right here, this is VID's homepage or home screen for the SCADA system we operate. It's got several tabs. You've got reservoirs that you can click on and view. The different color that you see here just represents different pressure zones. So some of these zones do not have a reservoir associated with them, and that's what would be considered a closed zone. But we also monitor water quality. We monitor the facilities such as pump stations, regulating stations, plants where we're monitoring water quality so we can actually see the facilities itself. We're monitoring the flows and the pressures, and obviously those correlate with each other, especially if you have a hit fire hydrant. You can see, increases in flows, drops in pressure. So our SCADA system, any SCADA system is really useful and provides a lot of information about what's going on out in the distribution system. All right. SCADA and radio. So how does that information make its way back to you? It's through these radio communications, otherwise known as telemetry. You will see these little antennas on top of reservoirs or at facilities, and it's usually angled towards some kind of a repeater. Those repeaters will take in that information and then send it on to some kind of controller. You got an image of a SCADA cabinet. You've got different types of antennas here, but this is just some of the stuff that we have out in our system at VID. All right, let's do a little bit of telemetry math because, why not? So in this question, we're going to be doing a 4 to 20 milliamp problem. And so the question reads, you have a 4 to 20 milliamp transducer measuring a standpipe with a maximum sensed height of 120 feet. Your indicator is out of service, so you've hooked up your digital voltmeter which reads 16 milliamps. What is the water level? Well, we start off by taking the voltmeter minus four, or excuse me, yeah, the voltmeter minus four minus it should be in MA, not MV, but milliamp reading minus four. So if we punch that in, you get 16 minus 4 over 20 minus 4, which would be 12 milliamps minus 16 milliamps. And so right away you can see that that's about 3/4, if you run the math on that, or 0.75. So you take that 0.75 times 120 feet and you get 90 feet. So you'd have 90 feet in that reservoir or standpipe, excuse me. So that's just a quick example of milliamp telemetry math. All right, here we have just what a couple of our pump stations around VID look like. Usually we try to keep them inside buildings just because the weathering, the noise that they make, security reasons. They can be unsightly. They do make a lot of noise. So if you can put your pump stations inside of a building, the public typically likes that. Okay, pressure regulators or pressure sustaining devices. They could be located in some type of a flow control facilities, much like the pump stations. They were in buildings, or you could find them in what we would call like a doghouse, just a small cover that goes over the regulator to prevent any kind of vandalism, or it'll be down inside of a vault. It just depends on, how the system was constructed back in the day and what made the most sense. Nowadays, we try to bring things out of vaults just for the health risks that are associated with the facilities being down inside of a vault. Here you got different types of pipes. Here we can see that we have some steel pipes. A lot of times when you have steel that sits above ground, you're not going to actually coat that in concrete. Right here, you can see there's actually concrete mortar that's been applied to the outside. Anytime you have steel pipes that are underground, having that concrete mortar on them helps to protect them. This is probably a ductile angle, looks like maybe a 22 and a half. And then steel pipes above ground are usually coated in some kind of an epoxy. Other pipes, you've got PVC here. That's going to be buried pipe. You don't want to have that sitting out getting damaged by UV. You got ductile iron pipes. Ductile is a great material. It's really strong. Um, Not as, I guess, corrosive as cast iron pipe. And then you've got asbestos cement pipe, AC pipe. And this is that bad stuff that you no longer allowed to use because of the friability of it and the cancer mesothelioma that's associated with it. We got different types of meters. You got Venturi meters. You've got compound meters, positive displacement meters, ultrasonic meters. It just depends on what the application is, and if you're trying to measure, large flows, small flows, it just whatever the end user is using that water for will dictate what type of meter is likely to be installed. Cathodic protection. This is a science in and of itself. It's using what we call anodes to protect steel pipes from premature corrosion. Like I said, there is a science behind cathodic protection, installing the right number of anodes, the right size of anodes, the right type of anode. It all has a factor in it. You have stray currents that are, potentially going to eat away at the steel on pipes. And so that's why, like I said, you cover them in concrete to help add that extra layer of protection. Record keeping, very important. Obviously, you want to be able to maintain real accurate records. And it's not just the location of where your infrastructure is located, but also all of the legal requirements that go along with your infrastructure, such as easement records, uh, other kinds of documents, knowing who has prior rights. Yeah, there's a lot of record keeping that takes place in order to be compliant in the water industry. Water quality is obviously the biggest thing that people try to hang us on in the water industry. So, using backflows to prevent end users from being able to push water back out into your distribution system is, really vital to the protection of any system. So we'll cover a lot of this later in the semester. Safety practices, obviously, you could honestly teach an entire semester course on safety. So we'll touch on this later in the course. I think around week 5. Yeah, go down deep enough into anything, and you will find mathematics. So obviously, we're going to do math this semester. Everything involves math. It's just how it is. Administration. It's important. I know some people love to fight the administration, but it really is what keeps things moving, keeps things organized. And for those of you looking to move up in the water industry, learning how to work with it is just as important. Right. There are a ton of positions in the water industry. So some of you might not actually be interested in becoming a water distribution operator, and that is quite all right. Some people find great pleasure in just being an inspector or being a locator, not actually operating the distribution system. Some people really dig water quality, construction. There's a lot of fields that go into the water industry. Not all of them are out in the field either. A lot of them could be in office, like I said in the last slide, an administrative position. So we'll touch on some of this later on. All right. But a lot of people take these courses because they want to be a distribution operator. That's what I wanted to be when I first set out to be in this industry. So, what is a distribution operator? Well, it is defined by the state of California as an operator is a person who works for a water purveyor and directly operates and or supervises the operations of a water distribution system supplying the needs of the customer. Operator responsibilities vary from agency to agency, which is true. But the goal will always be the same, which is to provide reliable water to the end user. Um, it is very important that we do our best to, fulfill that goal as well. Um, if the public loses trust in the operators or in the water system, it's never good for anyone. Look at like Flint, Michigan. You can look at other cities, like with the cryptosporidium outbreak that happened. There's just several examples in the past of people losing faith in the water system. So responsibilities. Operators responsible for water production, treatment, testing, storage, transmission, distribution, maintaining logs, keeping records, producing reports, troubleshooting faulty equipment, operating and programming SCADA equipment, and customer relations. And that's not everything, but that's a pretty good snapshot of what an operator is responsible for. And it's a lot. You know, um, every night when I was the duty officer, these are all the things I was responsible for. And well, with the exception of treating, I really wasn't treating, but I was testing, storing, distribution, maintaining logs. These are all things that I did on a daily basis as a distribution operator. So the other fun stuff is, and this is the stuff that I really like doing, was the water main breaks, hit fire hydrants, lateral leaks, private leaks. A lot of this stuff would come in every day, and made things exciting. It really gave me a lot of experience to share with you. In fact, so what does it take? Well, most companies or agencies are looking for somebody with experience. You should be educated. you know. Um, but as you can see here, certification is another thing. So, how do you get experience? You go get education. How do you get, once you're educated, you start to gain experience. And then once you gain experience, you start to get certifications. And then you start to realize that it just is one big circle and it never ends because you spend your entire life getting more education, getting more experience, getting more certifications, and it just keeps going. It never ends. All right. So, obviously, education, you guys are here taking courses, and I applaud you for that. You should be proud of yourself. Not everybody will do what it takes to sign up and make it this far. So, if you haven't already, pat yourself on the back. So, what are we covering in this class? We're going to give you a foundation from which to build your career upon. All right. Even after you complete this course, though, you do want to continue to take classes. Why? Because if you plan on moving up, um, you're going to want to get more specialized training. So, like I said before, this class is very generalized, and the other classes in this program are definitely more specific and detailed to certain subjects. All right. As an operator, you will gain or you will experience, working with pumps, motors, valves, pipes, electronics, computers, SCADA, water quality, testing equipment, sampling procedures, lab procedures, treatment equipment, techniques, and safe handling procedures when working with chemicals. Um, just about everyone I know who's an operator has experience with working with all of these things. So, but it's one thing to be, an expert in one area, but I think most operators are just kind of like a master of none and a jack of all trades. So, and that's certainly my case. I can't sit here and say that I am an expert at any one of those areas, but I've definitely touched on all of them at some point in my career. So, an operator is required to have knowledge about all of the previous items mentioned, plus knowledge in all applicable federal, state drinking water laws and regulations. That one's pretty big. Yeah, you really should know what the regulations are, because it's like a CYA thing. You definitely want to protect yourself throughout your career. You don't want to be, on the news for any reason whatsoever. You also must be able to read meters, gauges, technical manuals, plans, schematics, and many, many other things. Must be able to perform all necessary calculations accurately. Well, like I said, we're going to touch on math this semester. That is for sure. All right. A lot of you are taking this course so that way you can apply for higher level certifications, and that's definitely what this class is geared towards, is getting you ready for these. So we're just going to kind of breeze through this real quick. You can go on to the State Water Resources Control Board's website, and you'd be able to find real accurate information on how to navigate this certification process. So, who needs to be certified? Well, all treatment and distribution operators need to be certified. And you can see those definitions here. How do you receive certifications? Well, you have to pass the exam within the last 3 years. You have to get the number of hours or experience working on a system or treating in order to be able to receive that certification. Um, and for grades 3 through 5, you must meet experience requirements and submit verifications. So, submitting for distribution and treatment grade 3 through 5 applications, you're going to need more than just the 1 and 2. Listed here are all the requirements for your application. So you've got the signed certification. You have to get a letter from your supervisor. You have to show an organizational chart where you fit in that organizational chart. Um, You need, it says official job description, which is part of that, but in your supervisor letter, that's not what they want. We'll touch on that in just a sec. Um, and then a letter or permit designating the water systems classification. Reason being is that you can't work at a D1, D2 plant or system and expect to be able to get your D5. It just doesn't work that way. You can, I guess, exceed your plant or water systems classification by one grade level. So if you work at a 3, you can get a 4. If you work at a 4, you can get a 5. And that's kind of how that works. All right. In your supervisor letter, you're going to have them show you, or they're supposed to spell out how long you've been in the position, what are the duties that you do on a regular basis, the number of hours, which is really important. Like going back a couple slides, you saw that you need to have a certain number of hours in order to be able to receive that next grade level of certification. And it must be signed by either a chief plant operator or immediate supervisor. And then also the original signature is always required, and blue ink is preferred. That way they know it is an original and not a copy. Time frame for your employment, like I said, you need to be able to tell them how long you've been there and how long you've been doing these tasks. Um, Anybody, like I said here, an example, an operator has been employed with ABC Water District from May 1st, 2000 to present. Present, is the date the letter is signed. Okay, so make sure that when you're getting this from your supervisor, that he is filling it out. Because if your supervisor doesn't fill this out, then it's just going to get kicked back to you, and it's just going to take more time and effort on your end. So it's important that you're aware of what needs to get submitted. All right. Like I said before, you're providing them with the job description. However, you want that supervisor to state in their own words what specific duties that you perform each day. And that's because your job description could be more like a blanket, a cover all that, says that you do everything, when in fact, the reality is that you only do a few of those things. And that's fine. Leave that up to the supervisor to make the case for you. So that way, they're because I'm sure that they want you to get the next grade level of certification just as much as you do. So you could read through this on your own and see what it is that you need to deliver to the state in order to get that certification. Right. Again, list your position or title, and then the time frame you've been in that position. And then you want them to, list out everything that you've done, performed hot taps, water main installations, dead end flushing, locates, valves, maintenance, hydrants, perform all phases of meter installation repair, perform leaks. Let's see. So operator dedicated 20 hours per week per distribution duty and 20 hours per week to treatment duty. So basically what it's saying here is that, if your job only requires you to be a distribution operator for 20 hours out of a 40-hour week, then it's, you got to work that much longer in order to get the appropriate hours to be able to get that certification. All right, designation. Um, this isn't anything you do. This is something that's performed by the state and the administration at your agency or city. So water system designation determines if you have met the grade and site-specific requirements. For example, to obtain a D3 certification, you must have 1 year, 1,800 hours. As a D2 operator, you need to have a D2 or higher system grade at that specific site. So just kind of a recap of what I talked about previously. Supervisor's letter closing. So the last thing that needs to be declared from the supervisor, verifying that all the information provided on the letter is accurate. Um, if it is not, and that supervisor is fluffing or fabricating some of that information, they can be penalized just as harshly if they are making these false statements, as stated here. States that The state board may suspend, revoke, or refuse to grant and renew any certification due to submission of false or misleading information. So that goes both ways. That goes to you and your supervisor. The org chart, like I said, just shows you where you sit in the organization. And that's just so that way somebody who's, let's just say a water conservationist, they probably can't get a D3 as a water conservationist or an engineer. The engineers might not be able to get a D3 because they're not actually putting their hands on the distribution system. So that's why they want to see where you sit in that organization. Description of job duties, like I said, this is just to kind of give them an idea of, what they're saying that you should be doing. All right. Any questions on that? Let's move on. All right. Certification. All right. So passing this class and obtaining your distribution cert from the state is your foot in the door. Uh, Having certifications is likely going to give you an interview, but it's not going to guarantee you get the job. The reason being is, there might be somebody out there who doesn't have a cert, but maybe they have requisite experience that is what the employer is looking for. But you're more likely to get an interview because by having these certs, it shows that you are dedicated to the industry and that, this is something you really do want. So these are all different kinds of certs that you can get. You can get your D cert, your T cert. You could be backflow tester certified. And then to be a cross connection control specialist, you actually have to have your backflow tester cert. You could get your CWEA certs, lab analyst, class A. There's a whole bunch out there other than these. I don't feel like this is the complete list because it certainly is not. Operators must be able to commute effectively, both verbally and in writing. And that is very true. You are going to write a lot of reports and you are going to talk to customers. So being able to do this and do it well is important. Of course, establishing, effective working relations with fellow employees, other agencies, other districts. It's all very important. We all are ultimately trying to achieve the same goal, which is to provide safe, reliable water to our customers. So working together as a team is important. So this slide here is actually not completely accurate. When I, used it a long time ago, there were 24 member agencies of San Diego County. Since then, Fallbrook Public Utility District and Rainbow Municipal Water District have both detached from the San Diego County Water Authority. So now there's only 22 local member agencies. Reason being that they did that is because they sit in North County and the fee that all agencies pay is the same all the way down. So basically, if you were considering where we get our water from, which is Metropolitan up north, they were paying basically for that first couple feet that, if you will, of the driveway. But even though they weren't driving the whole length of the driveway, yet they were having to pay the same as, the water agencies, down at the bottom, like OTI. So that was a reason for wanting to get out of it. Plus, they felt like they could get the water cheaper um, through Eastern. Well, so that completes our first PowerPoint presentation. Please email me with any questions you might have, and I really look forward to the semester with y'all. Thanks. Bye.